I'm going to go over the two math problems on the last assessment. You're going to need to have your assessment in front of you so you can read the question. I'm just going to put the answer on this paper. The first question says, imagine you have 500 grams of steel and 175 grams of water. You pour boiling hot water, which is 100 degrees Celsius, onto the steel into a cup, which represents your system. So this is a standard calorimetric problem. The temperature of the steel was originally at room temp, 21.3. After 3 minutes, the system reaches equilibrium. Everything inside the system is the same temperature. It's 80 degrees. Mathematically show how energy is transferred in the system. So what you need to do first is list the variables that go with the specific substance. So I have Q, M, Cp, delta T for steel, Q, M, Cp, delta T for water. It told me at the very beginning the mass of steel was 500 grams and water was 175. The specific heat of steel at the very bottom of the problem is 0.46 joules gram Celsius, and then water 4.184 joules gram Celsius. Alright, so it says mathematically show how energy is transferred, so that means we're solving for our Q's because that's energy. So the only variable I have left is the delta T, where delta T equals T final minus T initial. Same over here, T final minus T initial. It's always like that. It says you pour boiling hot water at 100 degrees Celsius. So that would be the initial temperature of the water. The temperature of the steel was originally at 21.3, so that's the T initial of the steel. After 3 minutes, the system reaches equilibrium and everything inside the system is the same temperature, so the T final is the same for both substances. On your delta T for water, it's going to be negative, which makes sense because it's exothermic. All exothermic substances have negative delta T's and negative Q's. Therefore, my delta T up here is going to be negative 20. 80 minus 21.3 is going to be 58.7, which is a positive delta T, which makes sense because the steel would be absorbing energy endothermically. So you have endo and exo. Alright, so now that you have all your variables, you can calculate your Q. So Q for steel is 500 grams times the specific heat times the delta T, which would get us 500 times 0.46 times 58.7. A positive value, because it's endothermic, it's absorbing energy, 501, and the units are joules. Celsius cancels out with Celsius, grams cancels out with grams, you're left in joules. This is how much energy is absorbed endothermically. That's half the problem. The other half of the problem is to solve for Q of water. So how much energy did the water give away? Q equals the mass, 175, specific heat, 4.184, and the delta T is negative 20, which is going to make our Q negative. So I have 175 times 4.184 times negative 20. Gets me negative Q equals negative 14,644 joules of energy. This is how much energy was transferred exothermically from the water. The difference between them is 1,143 joules. This is energy lost to the surroundings. So the difference between these two values.